Hello and welcome to a new episode of the DevOpsSpeakeasy podcast. My name is Baruch Sadogorski. I'm head of DevOps advocacy for JFrog. And with me, my amazing co-host, Kat Cosgrove, developer advocate with JFrog. And we have a great guest today, Ravi Lachhman. Hey, Ravi.
Hey everybody, what's going on?
Thank you for coming to our show. Welcome
Thanks
to
for
the
having
Devil
me.
Speakeasy. And we have a tradition now. We 11 episodes in. That's the time to coin some traditions. And and our tradition is the first question. And the first question is, who is Ravi Lachhman?
That's a very difficult question. It's right here. Ravi Lachhman. I'm Ravi. I'm an evangelist for Harness, so we're a continuous delivery as a service company. I live in the Atlanta area. I've been doing software development and software architecture for over a decade, so very excited to be talking here on DevOps Speakeasy.
This is cool. So I guess we're going to talk about Harness like a lot. Right, because I don't know how many people know about Harness. So I think we should start with the basic question. After we ask who Ravi is, let's ask what is Harness?
Absolutely. So Harness is a continuous delivery as a service platform. So all of the, let's say, confidence building steps that you need to deploy software, Harness is an orchestrator for that. So let's say us three were a team here on DevOps Speakeasy. So we're a software
We are a
development
team
team.
for sure.
Yeah, we're a small dev team. We're part of a bigger dev team. There's a lot more than just building the software, right? So a lot of times you hear folks say CI/CD, like Kleenex or Coca-Cola. It's the eponym or eponym. I had to look up that word. I forgot what the definition was, but it's like something that means something else. We focus on the continuous delivery. So after the artifact is built, getting that into the systems that you need to deploy. So there's lots of confidence building steps. As people, we all interpret requirements differently. We're emotional, and so making sure that there's a consistent way to interpret, the expectations, a consistent way and a safe way to deploy. We wrap it up and bundle all that up. So your approvals, your automated tests, your canary releases and deployments are all by convention on our platform. So pretty fun stuff to work on.
Interesting. I'm thinking about. I obviously always take it to the place that excites me, and this is all about metadata, right? This is all about after you. How do you know what is approved, what is not approved, what status are you in, how the decisions are made? There is a lot going on about it, and I would say it should be very different for different organizations and different teams and different technologies. How can you unify all that?
Yeah, it's really difficult. Like I must have been probably on like a dozen dev teams over the last like 15 years. And there's certain things that are like I can take like job to job, and there's certain things that I can't take job to job. So let me start with what I can take job to job. So most of my background, I've been writing Java for a while, right? That's the language that I kind of grew up on and building large scale systems, Java-based systems. And so Java as a standard, as a language, there's common design patterns, there's commonalities in the language. And clearly what you're building is unique, but there's a lot you can carry with you with skills. How we go about deploying is different on every single team. There's been pretty much no similarity in our deployment process, from when I came out of university to even today, right? Like the rationale behind that, it's where all the technology comes together. It's also where all the people come together, right? We all have our own interpretations. The systems are made by people, so they're fallible, right? And going back to your point, that how do you know where certain things are? It's the whole rationale behind having a deployment process is confidence as people. Like again, us three on a team, each one of us will interpret what success is differently because we're the sum total of our experiences, and so that is what we try to harmonize at Harness, right? It's like, hey, we all have different ideas, so we're able to model that Let's say every organization is different. We see a bunch of organizations, large and small, and everybody's confidence building process is different. And we help model that on the platform. And also it helps visualize like what people are doing in terms of a pipeline. And so as your application transverses the pipeline, multiple team members from different areas are able to see how stuff is progressing.
So a semi-related question. You said that the deployment process has been different at like every place you've worked over the years. Do you think there's like undue pressure being put on engineers to be experts in more and more and more technologies these days? Like the resume requirements for an engineer is getting a little bit out of control?
I absolutely do think so. It's something that I'm actually very passionate about, like as a detractor for this type of practice, right? Like if I showed you what my skill set looked like, when I came out of university, over a decade ago to now, there's a lot more infrastructure focus as a software engineer, which is kind of odd, right? There's a company that plays movies out of the Los Gatos area, and there's a company that sells books out of the greater Seattle area. I think you know who those companies are. They really are pioneers in what is called full lifecycle development. So if you write it, you run it, right? So that if with that merging of thought, if you take a look at the DevOps movement, that's literally it. You're like a one-person shop. If you write the feature, you run it. If you build it, you run it, right? And so with that, it requires a lot more skills. I think the skill sets that I picked up, let me focus on the last like 3 or 4 years, were all infrastructure related tasks. Like, I have to learn Kubernetes. I need to learn Terraform. I need to learn these APIs to deploy in GCP or to deploy in AWS. And it's really, really difficult. I'm the same person. I always say I've gotten larger and grayer in hair, but I'm still the same person, right? But my experience as an engineer, it's a little bit different than, let's say, what an infrastructure engineer would have. And there's probably some other rationale why this is occurring too. There's been a lot of codification in a lot of areas that wasn't there before. And so as a software engineer, I'm used to iteration, right? I was actually chatting with some people internally today about this. Like, hey, as a software engineer, if you watched what it took me to write software, you would say it's ugly and make fun of me. You literally Google all the stuff. You try 2 lines of code every 10 minutes and run it 50 times. And then you move on.
Like my first draft of something functional is hideous. And I would never want anybody to see the code of, I don't want people to watch me code.
Yeah, I don't know how people do pair programming. I'll be embarrassed, right? Let me Google that. Let me go in Stack Overflow. But and that's really it, right? So I'm used to iteration professionally. Hey, I've never gotten anything right the first time.
No, I don't think I think it's an unreasonable expectation to put upon others or yourself that you should always get it right the first time. Nobody is an expert in that.
Absolutely. But there are people that don't have that luxury. It's the infrastructure folks, right? So they're on the paradigm that let's say more traditional infrastructure folks, all the codification has kind of changed a little bit of that. They have to get it right the first time. If you misconfigure a server, well, it's physical. Hey, it's not, we're wasting time by not being able to access something, or it's turning off, right? Why is the power not going to it, right? They're in production all the time. There's no development environment to rack a server. You don't get the practice server, training wheels. I mean, this is it. You have to get it right.
You kind of do, right? You have your environments, you have your staging, you have your whatever. I hope people practice before they roll shit in production.
That's commonplace now, right, Baruch? So as a software engineer, I'm used to having multiple environments, right, to kind of test changes. The core infra people, maybe not. They might have a sandbox to try, but they usually don't have multiple environments. But today, let's fast forward to 2020, because of all the infrastructure as code, your software development team looks like an infrastructure engineering team, and vice versa. The infrastructure team looks like a software engineering team at some point. And so this is where the two mergings happen, in my opinion.
No, we're not expecting software engineers to be hardcore infrastructure experts, because that's unreasonable. There's too many security concerns to keep track of in infra. and on top of the security concerns you have to keep track of in software, it's already excessive. The sheer number of technologies and whatnot that software engineers have to know to get a junior dev job.
But I think that's what all the T-shaped people culture is about, right? So you do have the specialization, and it's very important because our limitations as humans and what we can know. But at the end of the day, we need to work together, understand the world of other person. But you don't really have to be very deep into everything they know.
My issue with how wide the T is getting.
Yeah.
That T is getting real wide. It's getting super top heavy.
It is, but I think it's not that it wasn't wide before. It's more like we pretended it's not wide. You know what I mean? The concerns were always there. The fact that we ignored security doesn't mean that we didn't have to care about security and now we suddenly have to. It's just a matter of we ignored it before and now we realize that that was a mistake.
I think it has to do with the velocity of what we're expected to produce, right? So actually, if you blend both of your points of view, it kind of comes together with velocity. It's like Baruch is actually correct. Like security just didn't appear overnight, or these domains didn't appear overnight. Like they require specialists, right? Because the cat's absolutely right. Like, hey, like each one of these specializations were there, but the kind of the where there's a lot of emphasis on the T shape is another item I always like to make fun of. Like, no, when you're hiring for a junior dev job, why do you need 5 years experience? Or you're hiring an entire IT department. I've seen like job recs before. It's like you need like 6 people. Like this is not one person by any stretch of the imagination. It is that because of the velocity that's kind of required today, that the whole shifting left mentality, right, or widening or biggening of the T is as I'll play devil's advocate. I'll pretend that you and Baruch are specialists in your own domain. So Kat, you're an AppSec engineer, and Baruch, you're a special infrastructure engineer, right? So congrats, or I'm sorry at this time, but like a lot of it's sharing domain knowledge with me in some sort of format. Like, hey, like we'll harp on security. Like, hey, as an engineer, I have to make more secure choices during my SDLC process, but I'm not an expert by any means. But Kat is an expert, but she's only one cat, and there's like 20 of me on a team, right? So we're already looking at a disadvantage for Kat, and so like this is where platform engineering perspective comes in. Like, hey, you have experts that are able to teach, but there's also platforms in place for me. Like, I think the challenge for platform engineering as a domain, maybe not so much as a job, is that platform engineers are there to teach and build. I'm trying not to use the word platform too much, like the SATs, but I'll have to use it like platforms for other people to consume. So I'll pick on Kat a little bit. Like, Kat's our AppSec engineer on the team here, and Kat's domain is it's very application security specific, but like most domains that require a lot of expertise, there's only one Kat and there's like 20 Ravis. So we're going to multiply if it keeps going on from 2 to 4 to it's 16, right? But that's usually how it is. Kat's pretty leveraged or matrixed, right? Like depending how you look at it, that her expertise is not one-to-one for the team. She probably supports more than one team. So that's why that's why a lot of tooling and platforms, like if you look at what people are investing in today, is going towards of helping people become T-shaped without like going nuts, right? Like I'm not an application security expert. But let's say, just a quick plug for JFrog. Like if I was using something like JFrog X-Ray, I'll get information earlier on the development cycle on more hygienic choices that I have to make, right? So Kat's knowledge she knows what's hygienic and not. She can clearly say like, hey, if you're using this kind of meets our enterprise standard. So Ravi, you have to pick something from here. And that's basically it, right? Like, hey, it's shifting left, broadening the T-shaped skills, but you're also limited in choice. Where it gets detrimental is that you don't have a very strong platform engineering base. If you take a look at the book company and the video company, they invest heavily in platform engineering. Like they have very strong platform engineering teams. They're some of the more senior engineers who get to do that. Versus like let's say an average enterprise that probably has multiple focuses, or like let's say it's an insurance company or a financial services firm, they might not have a very strong platform engineering team because they have so much legacy that they have to keep up with. And that's where the challenge is, right? Like, oh, they do it, so you should too. But they have like 100 people supporting you to do something, right? Versus it's just you. So that's
so what you are saying is, okay, we understand that the world is more complicated now, and we can and the there are no parity between people who maintain every aspect of the broad part in T. So instead, where you are lacking people and expertise, you kind of cover with technologies and maybe less choice.
Yeah, like if you limit choice, it's like going to a buffet versus like ordering from a menu. Like if you're presented with like infinite choice, it's like analysis process. You just don't know. You're like, oh, it's the steak is too far. I'll take the lobster. Versus if it's on the menu, they'll bring it to me. Yeah, you know what? I'll take a hamburger or something. You don't have to go walk.
You've never seen me eat at a buffet, my dude.
Multiple plates. But that's spot on, Baruch. Yeah, when you limit choice, you can. A lot of times when you deal with a lot of choice, it's a lot of bickering that goes on. It's like consensus versus opinion development, right? Like it gets difficult to kind of navigate that.
So it's not about the software engineers becoming AppSec specialists as well. It's about reducing the workload for the one AppSec specialist you have. Yeah,
not becoming the bottleneck, right? Like if let's say, a very quintessential, like example would be, something that shifted left is AppSec, right? Like that,
yeah.
You're a lot of the tooling that that JFrog has, is kind of shifting towards giving information earlier in the dev cycle, right? So it's all going back to velocity, right? If I have to get something out in production, and that's where I'm bonused or like MBO'd on, if poor cat only has 8 hours in a day, she's not working 20-hour days, right? So part of, let's say, more traditional approach would be, okay, at the end of your sprint, at the end of, it might be a 2-week, 4-week, 6-week sprint, you need to have someone from AppSec sign off on the change. But, if you support 10 teams, you're constantly doing that and battling their deployment schedules. Versus, if you pick from this set of tools, we automatically bless you, right? Or if you pick from this set of libraries, you pass our automated suite of tests, you're automatically blessed. So like your domain knowledge you're able to get to the teams at their velocity. You become the bottleneck. That's
that makes sense. Yeah, but I think there is a problem here is that when you're limiting the choice for your teams, doesn't it prevent the innovation? Because the idea is that you want to run as fast as possible and come with new ideas. So for that, you want let people to be creative and do all kind of crazy stuff. And then it's up to you as an infrastructure engineer to find a way to provide quality, to provide security, to be able to deliver it on scale and redundancy and be able to maintain it. Good luck. I mean,
ooh,
that's too much. Yeah,
I don't agree. I don't. I'm sorry. I don't think that you need to give people like 100% free reign to use and do whatever they want with no consequences and no rules in order to get innovation. I think it's a bad idea to let people choose whatever they want with impunity and do whatever they want with impunity.
Well,
humans,
yes, but think about you wouldn't allow anybody in your team to use Kubernetes a couple of years ago. I mean, Kubernetes probably won't, or Docker more than a couple of years ago, like 10 years ago. Probably it won't pick up if no one would allow to use it.
Well, I mean, it's just the protocol for deciding. I mean, I don't think you say you have to use these same 3 tools until the fucking end of time. But there have to be rules in place.
Yeah, there's two sets of radio dials, and that's always like the hardest to get right. Like, I'll give you like my technology manager, like, my team credo. But
Mr. Manager.
I know, yeah, I'm a people manager now. It's scary. I have people. I know. But it's usually like two sets of radio dials, right? Like the one Baruch is mentioning is like, hey, you have to maintain the radio dial of innovation. It's what separates everybody, right, in industry. It's not fast and great. Versus the older I get, it's like at some point, okay, like we need business controls at some point, right? Like we can't have total free reign on doing something because we might be too bleeding edge, and we might be being detrimental to ourselves being too bleeding edge for either from a security standpoint.
You don't want to dreamcast yourself.
Yeah, from a security standpoint, from an architecture standpoint, to an operational standpoint. Like if we're the first team to do something, that means we get to support it because we're like way ahead of the infrastructure team, right? So going back to like, I was fortunate. A team I worked on, we were the first team going into Kubernetes a few years ago at one of my employers, right? So like, we definitely seen that occur before. But it's basically that, right? Like it's kind of a hybrid model, like giving people choice up to a point, saying, if you have to do this, understand you have to support it. Like saying, just when you take a look at something, if it's not like on an official list or like a technology roadmap, understand that we're going to have to come up with a playbook how to support it. So there's going to be more of an infrastructure emphasis on our technology decision than if there was something we already had, but which can be really fun, right? We could be the first team to implement, I don't know, pick a new technology. Let's say Ravi.io became a popular package, Ravar, I don't know. So we have to support 2 Ravar packages, right? So, and that's pretty much it. Just knowing that, hey, if we're doing something for the first time, we're going to have to be the ones operationally supporting that for a little bit until the rest it gets into the enterprise fold. And also, you don't want to stifle innovation. Like if you're going through, usually, if you take a look at platform engineering approaches, like most people say, you know what? Yes, the development team will have the most lax rules, like in dev environments. So from a security standpoint, they could use more risky stuff or less risky stuff. They could pick infrastructure that maybe is not totally blessed, but there needs to be a good reason why you're picking it, right? So like I say, enterprise architecture standard now, like, does it match the goals that we're going for? And are you okay about teaching people down the chain? Shifting right is another thing, right? Are you okay teaching the people on the right what the choices you're making? So there always is a happy medium for that, but it's difficult to get right.
I think that's a good compromise.
One of the nicer ways to implement this, if you want to innovate, go ahead, but we won't be able to give you the support that we give to the tools that we know, is actually doing it with money, with budgets. And we know those organizations that have the infrastructure team, and if you go by their recommendation, they will provide you tons of stuff that they already paid for and they have in their arsenal to give you, right? So for example, but they also won't limit you to use anything else. So basically, you say, you know what, I want to write my next microservice in Go. They will come and say, well, fine, we support Go. Here are the IDs that we already paid. Here are the hours of consultants that can help you that we have in the pool and are already negotiated. And if you come to them and say, you know what, I want to write microservices in, I don't know, in Rust, they will tell you, well, nice, good luck. Unfortunately, we don't have a lot of resources to support you, but definitely come back with your findings because maybe we should actually start supporting that.
That's very fair. I think it's knowing when to pick your battles too, right? So like a lot of times there's non-functional requirements that people will bicker about. It's not the features. Like let's take Rust as an example. We'll just play with Rust now. So let's say we're going from Go to Rust for Baruch's example, and Kat and I are on the Rust development team. Like, yeah, Rust is fast. Mozilla did it, so we can do it too. Where the pushback that you and I would get, like we might build something in Rust, but it'll be all the non-functional stuff that some sort of infra team or platform engineering team would provide. It's like, okay, yeah, we're here at Acme Enterprise. Do you know that we have SLAs we have to maintain? So how are we going to monitor it, right? Like that's always a problem. Like, oh, we don't our Datadog or our App Dynamics, like we don't have a Rust interceptor for it. You might be able to log stuff to Splunk, but we need to be able to profile your app. And so there's where a lot of the pushback will come. It's not necessarily how we built the feature, but like there's some sort of standard that an enterprise app has, in an organization. Like it has to be managed, it has to be monitored, there has to be some sort of recovery process. Like, can you prove those things out? And it's like picking your battle. Like, let's say Rust became more, it's always everybody's favorite development language on the Stack Overflow surveys. And like, let's say like, you know what, we can prove that, hey, the tools that we have to do these things do have hooks for it. It's a lot less of an argumentative task at that versus you're doing it for the first time. And so that's where like, hey, incremental success kind of wins out with the, also they might give you a risk exception. A lot of times if, let's say again, we're going totally rogue and our team decided to do something and we feel very strong against it, we assume the risk. So a lot of the like what Baruch was saying, like a lot of the operational support we would probably get might not be there for us at the beginning.
That's probably a hill I would be willing to die on over a language choice. Honestly. But that's
so here is okay. That's fair enough. But what if, as Ravi said, there are tons of requirements, observability and security and logging and API endpoints and what's not, that you already have as an infrastructure that you can just get for free, only if you will give up your language of choice and just switch to a good one, decent one, maybe just not the one that you are super excited this week.
If it's still a good language that I like, I mean, if we're talking about, no, you can't write Rust, but you can write Python, I would be like, fine.
Yeah.
Or Go, fine. But if it was, you have to write Java, I would be like, I am quitting. Like that's I'm sorry.
Kind of like common for enterprises now, they have a polyglot support, right? Like it's like they usually it doesn't come down to like if you take a look at like what people are like, the real bickering comes down to, it might not. So let's take Rust again. Like, okay, we're going for Rust. Most likely most of our application is not going to be written in Rust. We're going to be calling it's going to be a aggregation of multiple things. Like let's say we're building an engine, so like the core processing part of our engine might be Rust, but we have a web interface. Like we're using Node.js and Angular. Like we're using multiple languages in our own application. So like bits and pieces of it might be unique, and then bits and pieces of like a bulk share of it might be we're using open source, we're using third-party open source, we're using other packages that we didn't write. We're calling other pieces of, like let's say we have a login in part of our application. Some sort of central team wrote all the adapters for that in our enterprise, right? So like it's not an all or nothing argument, but it is like kind of a coy game of like we will take 20% of Rust and we will probably, a realistic example is yes, okay, Kat, like we're going to use Rust. Rust is the best choice because it's very performant for the decision engine that we're writing, but everything else is going to be like supported. So, but it does produce interesting operational problems. Like where did the problem occur? But we can figure that out.
And that's why microservices are cool because they make it easier to do that.
Exactly. And be flexible and let people do what they think is the right answer for this particular question. But it brings us all the way back to the beginning of our conversation. And my question is how versatile, how universal tool like Harnest have to be in order to support this less rigid selection of tools, techniques, instruments that people are expect now in the modern world.
Yeah, I think if you take a look at like very modern ways of solving problems, a lot of it is problem-centric solutions, right? Like we have goals, like, okay, we want to deploy quicker or we want to deploy safer. And so a lot of the implementation details are, there's ways to abstract that out. If you take a close look at the Harness platform, I always like to tell people we're like the blackjack dealer. So I'm the dealer and Baruch and Kat are, hanging out at my table here in a casino. And I'm like, whoa, Baruch, like you need to double down on that 11, like stop. Or like you should put something. Like it's giving you hints, right? And that's a lot of what the Harness platform does. So like we're like the blackjack dealer at that point. For all of the intricate technology choices, it's two models. We're a blackjack dealer and we're like Bob Ross, the person who paints like trees in a half an hour on public access TV. And so you basically load up your palette or your painting weasel with different colors, which is different cloud adapters, different deployment areas. And then what Harness will help you do is assemble that in a very beautiful painting. But also what Harness will help you do is like the dealer, like, hey, if you do a canary deployment, how are you promoting the canary? Like, you shouldn't double down on that. You're drunk, get out of here. Or how are you validating something? And so it's actually pretty simple to use. Like, to Baruch's point, yes, like there's loads of technology that we have to support. We kind of do it with like native support and like also convention. Like, hey, if you do X, you have to do Y. Or if you did B, A had to occur before B. And we really enforce that. We make it quite simple for people to consume. So we support the new and the old pretty seamlessly, which is the exciting part for me. It's like, hey, you can really pull off these advanced deployment techniques with literally a few clicks of the mouse and by convention.
So it sounds like Harness makes it easier for software engineers to not need to have like a super wide T. Because if you've got tooltips, for lack of a better word, built in, preventing you from doing some dumb shit, all you really need to know is how to plug it in. And from there on, Harness is going to hold your hand at least a little bit. So you don't need to.
A lot of interesting about, like, if you take a look like at a customer journey that we go through, or let's say like, hey, we're a customer's taking a very close look from a proof of value, proof of concept standpoint. It's funny that they bring a lot of teams that usually don't talk together, so like the infrastructure engineering team, because it's easy for people to input expertise into Harness. So like, again, I always like to pick on Kat. Kat, you are the Terraform expert on the team here. Congratulations.
All right, cool. Thank you.
Oh, she is the Terraform expert on this particular team. That's very precise.
Yeah. So Kat, she's an expert in Terraform. So perfect. And so you're able to like kind of say, I don't want to deal with Ravi like more than like once every 2 months that he has all these funny questions. So I'll give Ravi a Terraform script, and I'll make it in a way that he can just load it into Harness, and it just prompts him for a couple key tunables that we usually would ask. And Ravi has never seen Terraform in his life, and so he wouldn't even care if it's Terraform or Ansible or Puppet or Chef, right? Like, it doesn't matter at that point. It's just we're able to give. Part of his job is to lay the infrastructure down at deployment time, and that's a lot of what we support. Right? Saying, okay, yeah, like Kat certainly has expertise. She'll be the one kind of templating out this portion of it, but it plugs easily into the platform, and we can template out the whole workflow pretty simply. And that's when people see how simple it is, it's usually like, oh, yeah, we know what we're talking about.
I like that, 30, 40 minutes into this podcast, and I'm already an AppSec engineer, a Terraform expert, and I suddenly know Rust. I feel so smart.
You have T-shaped skills. I mean, this is legitimately what the market requires now. Congratulations. And see how difficult? All those skills are so different. Like, that's my big gripe with it. Like, they are so like, I could write Hello World in Rust, or I could write Hello World in some sort of Terraform that spins up some sort of EC2 instance. But yeah, like they are definitely different domains. Code is not like, they all do something different, right? Like,
yeah,
just that they're represented as code. It's like, oh, the software engineer has to know. They know code, right? Like, oh my God.
I don't actually know Rust, listeners. I would like to learn it, mostly because cargo yank is about as close as you can get to saying yeet in a programming context. But I don't actually know Rust, so please do not come to me with Rust questions. I am not a Rust expert.
And generally speaking, cargo is one of the least fucked up dependency managers. So
is it?
Yes.
Good for Rust.
Rust cargo is pretty decent. I mean, it has.
That'll be real fucking refreshing after Go. Sorry, Google.
Not only after Go, after almost all of them. I mean, if you ask me to name two, I cannot say perfect, but decent dependency managers, that would be Conan and Cargo.
Okay.
Yeah.
Noted.
Yeah. So
Ravi, do you actually know Rust?
I know how to spell it. It's always like, I don't have anything that would be a good fit for Rust, right? Like, it's always Stack Overflow's #1 love language. I get, like, from a software engineer perspective, like, I get why it's so popular, but it's just like hard to find people with Rust skills, right? Like, it's all like, if you've been using it, Usually it's like if Go and C++ had a baby, you get Rust, right? Like
Yeah, I mean, it's used for embedded development.
Yeah, like
And,
your Mozilla is
it's not
powered by Rust.
automotive. Yeah.
This is huge. I mean, embedded development is huge. We spoke about how edge computing is the new big thing, is the new cloud native. So, I mean, saying, well, only edge computing uses it is just saying like, well, yeah, only 5 billion people are using it. I mean, no, seriously, that's the next big thing. And if Rust is a good fit for edge computing, Rust is the next big thing.
Yeah, I mean, not to give away my like entire conference talk, but there are 20.4 billion edge devices in the world.
It's a lot. Ooh. Oh yeah, swap up is coming up. I'm excited.
That's a great segue, Kat. Well played. All right, let's talk about Swamp Up.
That's why you pay me the big bucks.
Ooh. Nice. Ravi, Swamp Up. You are one of our great speakers, and let's talk a little bit about your talk. What you're going to talk about?
Absolutely. At first, I wish we were doing it in person. The whole situation is crazy.
God.
I'm looking forward to hanging out with you guys. And,
I'm going to take you out for drinks and.
As many times I've been to the Bay Area, I probably been to San Jose one time. It's always like this 5-block area of San Francisco that I cordon off. And so Tuesday's like, I can see. I would legitimately be like the second time I've ever been to San Jose. I was like, woo, I get to see San Jose.
Me, it's not that San Jose is a very attractive tourist location, but the hotel that we were supposed to be in is
the hotel was popping, dude.
They're always like stellar hotels. Like, I love
and it was like an old luxuries hotel from they don't build like those anymore. So this is one of those. But you know what? Next year we're going to do it in person. It will be amazing. But online it's going to be very, very nice as well. So what are you going to talk about?
I'll be talking about how to get a yes. So a lot of what we do in software development, which you don't teach you in school, and the older I get, is there's a lot of negotiation that goes on. That's it. You're always negotiating something. Either you're handed, like going back to like I have to appease Kat, the AppSec engineer, with her automated ways or manual ways, but that's just one facet of it. You're constantly negotiating. And so one of my favorite books I got when I came out of school and started working at a consulting firm was like how to get a yes without like offending people. And it really talks about certain ways that everything's the art of negotiation. There's lots of ways of getting a yes by early negotiation, surfacing up data early. And so we're talking about that is core to continuous delivery. So we partake in this Linux Foundation organization called the Continuous Delivery Foundation, or the CDF. I think Baruch and I are both on the speakers bureau for that. So, and the big goal for that is basically what we're talking about. Like, how do we negotiate yeses, like cross vendor, right? Like what's the best way to get a yes or a no quickly? And the sales argument is you don't start selling till you get a no, right? Okay, no to Rust, well, why? Let me start selling you to this at this point, right? And so the talk will be kind of going through that. What are some ways that people negotiate yeses inherently, and then what are some of the tooling that the CDF and ourselves represent?
I'm smiling because great minds think alike. And I actually have, together with my co-speaker, Leonid Igolnik, we have a talk which is very, very similar to that. And that influencing DevOps without authority, how you can actually promote DevOps in your organization without being the big boss that can say, okay, we're changing our ways now, but actually going through it from the bottom. And it's a lot about influencing and a lot about conversations for getting to yes, and obviously there are a lot of techniques there come from the same book or couple of books, getting to yes, getting past no, getting to yes in harsh environments and all that. So yeah, I'm very excited to see how our talks realign. Mine won't be on Swamp Up because I want one good talk about persuasion and getting to yes is enough. So we'll get yours, but I'm personally very excited to see what do you have to say about that?
Baruch, you're not actually speaking, are you?
No, I'm not, because every time I try to organize SwampUp and speak at SwampUp at the same time. I realized that it was a mistake and I need to give up one of those. I'm not sure I'm ready to give up organizing SwampUp, so I try to give up the speaking.
Well, I'm prettier anyway, so.
That's for sure. And you're a better speaker, and for sure, you two are the definitely more deserve to be on the agenda than me. Ravi, I wanted to ask you, did you adapt the basic concepts of getting to yes, getting through no, to continuous delivery, to DevOps, and if in yes, in what way? Maybe you can give us one spoiler example of how the sheer theory of getting to yes is actually translated to continuous delivery for in our example.
Yeah, absolutely. Like a lot of it can be a lot of the parallels I parallel is I'll give you this is going to be like a 2-minute example. So I always like to compare what it was like getting a credit card in the 90s versus like getting a credit card today in 2020, right? So like if I'm a little bit older, so I remember when I was like 18 in the 90s and trying to get like an American Express card, you literally have to call them, tell them all your information, and then someone was like, okay, that's cool. And you have to wait like 2 weeks for a yes or no, then another 2 weeks to get the credit card in the mail. Versus today, I can literally go on my phone here and go to Amex.com or the app and get a platinum card, like Apple Card ID, in like 60 seconds, like flat.
Yeah.
Like it's ridiculous, right? But the number of decisions that American Express makes today, like outweighs their decisions that they made in the 90s, right? And a lot of reasons that they had to do that was core to automation. And so they're able to say this is an acceptable amount of risk, and they have decided that, and they're also able to do that with the data, like surfacing data and surfacing decision criteria. So the DevOps trifecta of people, process, technology. Technology is easy, like hey, I built a system that has 5 nodes because it can take 2 concurrent failures. Given process, sure, we have a change control board, but people. That's it. We're the hard part, right? So a lot of like what the CDF and Harness tries to do is allowing you to automate the yes. So a big part of the talk is automation of the yes and giving you a quick no. And so saying, okay, there's a certain risk tolerance. If you don't pass a certain test, clearly you're going to get told no, right? So if you're able to know that kind of contract negotiation up front, you can either provide a lot of backing data why it didn't fail and kind of go forward, or just assume that you're given a lot of responsibility to get a yes. But you know what you're working with. So a lot of times also, this might be giving too much of the talk away, but the art of sales, right? So a little bit, I spent some time before I came back into more technical in sales. And a lot of it will be like, we have to understand all the decision makers, right? So let's say I was trying to sell you and Kat a new car. Congrats, you're going to buy a Porsche. It's Ravi Porsche Atlanta. I'm selling one. So, well, I'm not selling, no, it's just like, but as an example, like, you have to know your customer, right? Like, hey, like I need to know what Baruch likes. I need to know what Kat likes. Kat wants a convertible, Baruch wants SUV. They have, this is why they want it. The same thing can translate into system development, right? Are we internal customer first? Are we external customer first? Knowing your customer is also very important. And so that's, without giving away the entire talk, some of the main talking points I'll be talking about.
Yeah. So first of all, I do want an SUV, but I have to admit you cheated. Instead of talking how hard it is to convince people and to change their mind and to go through no in human interaction, you just automated all the decision making and you don't ask anyone for a yes or a no anymore.
Well, it's better to ask for forgiveness than permission, right?
Yeah. A lot of times it's automating the yes, right, which is the challenging part. There's clearly things that fall outside the normal bounds, but it's coming. The part of it's like coming together. So like when you're building anything that's like rule-based development, like going back to the credit card example, like one person at American Express didn't decide what made me get a platinum card versus what failed me. Like even though it's easy to change those systems, it's the business logic behind it was developed by like hundreds of people with risk modeling and whatnot. And so like a lot of that getting to the yes is just bringing people together to understand the rule set ahead of time and then implementing that in an automated fashion. Like the implementation is like, it's nothing, right? It's so simple, but exactly what steps you implement, that's the bickering that happens. So that's That's pretty much like 2/3 of the talk. please see the real talk, the whole talk.
Please see the real talk. It's long. I mean, your talk is like half an hour long, so you didn't spoil much.
Yeah,
Come to Swamp Up 2020.
but yeah, it's interesting how a talk with almost the same title, your and ours actually speak about completely different things. That's fun. But we took the harder route. We are talking about people, not machines. Machines are easy, predictable, right, and deterministic, and short feedback. People, not so much.
No, we're dumb, panicky animals.
Yeah, we're very emotional. We have emotion.
We are. We dig our heels in on dumb shit too. So.
And we are irrational, and our feedback loop is screwed up. One of the things that annoys me the most is when you ask people, and for something that you expect a honest answer, you never get it. It's like really annoying. Never happened with machines.
No, I've hated an entire product before just because I didn't like their logo.
Yeah.
Just flat out, I think this logo is like weird looking or creepy or
whatever. And the funny thing is, they would ask you why you hate it, and you would be so embarrassed to admit that it's because of logo that you will come to dump excuses and call things that which are completely fine as bad, just not to admit that you hated the logo.
Yeah, probably. No, I can't be sure of this, but I think part of my like love-hate relationship with Go is that there are a lot of things I love about the language, but that fucking gopher freaks me out.
Yeah, it looks like a hybrid bear gopher. I don't know.
It does, and it looks like one of those toys that you like squeeze and their eyes pop out, but it's like permanently squeezed, and I don't like it.
It is creepy. It is creepy.
It's creepy.
Well, it's hard for us to give it depends who you ask. Like we're from 3 different parts of the world, right? So like giving negative feedback might be more difficult for some of us than others. A good example of that. This might be a little off topic. One of my good friends. One of my favorite shows until I learned it was fake was House Hunters. So
is it fake?
Yeah, I didn't mean to burst your bubble. So so my friend, he was on House Hunters in Atlanta, and the irony of it was but they have to be under contract to go on the show. So they already bought the house before they have to find 2 other houses to
oh man,
talk smack about oh, we don't like the color of the shelves in this room. It's like we already bought the other house.
Complaints are always so stupid.
Yeah, that's exactly right. Yeah, that's what going back to hey, giving hard feedback is sometimes easier and harder. It shows how hard it is to find fault in things. Like my friend who was on the show, it was so funny because when they were showing the house that they bought, half of his stuff was already in the house. It's like, yeah, this is the right house. He had a viewing party. We're sitting on the couch that they were showing before they bought the place. Yeah, dude. But that's usually it. It's he's like, the hardest thing was for us to come up with reasons why we didn't like the other 2 houses. It's they were both nice, but we already bought our house.
That's gonna ruin it.
Sorry, HGTV. Didn't mean to spoil it.
I don't have cable, so I don't really get to watch it that often anyway. I got to be in a hotel, and ain't nobody going anywhere. So
yeah, that's how I watch TV. Also, it's oh yeah, I can watch cable at a hotel.
You know where I watch all those shows on a plane actually, the direct TV. That's the only time.
No, the plane is for shitty movies I didn't see, movies that I want to see but not enough to pay $16 to see it in theater. The Harry Potter Fantastic Beasts one. I wasn't going to pay $16 to see that in the theater, but I will watch it on an airplane.
Yeah.
I always like to start at the end of the movies on an airplane and work my way backwards. I'm let me see what this movie was about in the last 2 minutes. Yeah, and then okay, I'll start. You have the complete control. I'll just skip to the end to see what they're gonna do.
You know what? I'll try that. I'll try that for you. Then if I'm ever allowed on an airplane again. God, I miss airplanes.
Yeah, I like to cheat in the movie. That's why I like computers. See, Baruch automating the yes is cheating. So just give me the answer and then let's see let's work our way backwards. How we can.
That is a good thing about computers though, and about automated deployment rules or delivery. Sorry, you guys say continuous delivery. That is the good thing about it, because you do already know the conditions. You are already aware. You can like work backwards if you want to.
Yeah, you know what good looks like, right?
Yeah.
Yeah.
That's the great part about it, because I think if I go back to like when I first started my software engineering career, I had zero visibility what a deployment looked like. Like I had no idea what the steps were. I had no confidence in what, I was discovering things as they came about. Like, okay, we have to package it this way. Okay, can you write this documentation to hand off to XYZ? Okay, can you put these in a properties file? Okay, can you change the properties? Okay, and it was very ad hoc. I mean, the ad hocness has definitely been, less and less, but there's still a little bit of that. Now I know that it might be just more have more like of a lead position. Like I definitely know what the steps are, right? Like, hey, I absolutely know. It's all about giving that upfront data, because there's a pipeline. I look at the pipeline first. Like this is what the other team has to go through. I assume we're like at least 80% going to do that. So having that
a lot of my software development already looks like, fuck it, we'll just run it and see what happens. And I get an error, and then I fix that error, and fuck it, we'll just run it. And I get another error, just like work backwards through this like massive stack trace of problems. Thankfully, Python's like pretty explicit with its error messages. So usually I've got a good idea of what the fix is, but I already did that through like my entire software development process. I don't want to have to do that with my deployment.
Deployments are something else. I must have been to production hundreds of times in my career, and it always get a queasy feeling. Like another a good one to talk about is like, I always like to ask people, when is your deployment over? And it depends who you ask. Like it's a very intrinsic and telling question of their organization, right? So I'll pose the question to you two, and there's no right or wrong answer. Like when is the deployment over? Like I'll give you some insight of all the answers. I'll give you a second to.
What was the deployment? What?
When is your deployment over? Like when is the deployment?
When is my deployment over?
When is it typically?
Well, I will give you the naive answer, so you can tear it to shreds, obviously. And my answer would be, you have a commit. It went through the entire pipeline. It was verified for quality, security, passed all the security gates, passed all the quality gates, and then was progressively deployed. We deployed it as a canary. We saw that everything's good, no casualties in production, everybody are happy, and then we roll out the canary to our entire target, whatever it is, target devices, edges, or whatever it is, and then we are done and waiting for the next commit.
And Kat, when is your deployment over?
Mine is over when the first user uses the update that I've pushed out and it doesn't break.
Well, no, but this is the first stage in your progressive delivery. After that, you actually need to keep deploying.
Yeah, you keep deploying, but
yeah, both of your answers are very correct, right? Like I think Baruch's answer is a very literal, like very sophisticated answer. Like you'd automatically be in the top 10% of people I talk to on a day-to-day basis, like when talking about it. And Kat's answer is very literal, right? Like, hey, when the first user logged in, and a majority, I would say, most of the answers I get are, so it falls between the spectrum of what you and Baruch actually said, right? Like most people would kind of side with the deployment's over when the artifact has been delivered, right? Like that might be the most literal answer you can get. But when you start talking to folks like who really like gone through the process a lot, you start to say like, you know what? It's never over, right? Like it's over when our next deployment goes in, because there's always something going on. Like I would always get like, I spent some time in like financial services, and I was an app owner for a non-sexy application, but it was like a very internal, like, but it was an important internal. It was manages people pay time off. So I ran the PTO program for the bank. I was the app owner for that. So we would deploy, or we would build every day, but we would only release like once a month unless there was an emergency. And when we're going into like a higher environment or even into production, we would, without fail, we would deploy, and then we would, like a couple hours later, I would violate an SLA. Something we could, I don't know, like every time it was something else. And so like it was just like this uneasy feeling, and it never gets any better. Like, what's gonna happen now? Am I gonna get a PagerDuty alert, blowing up that something's going wrong? And it's always uneasy.
Well,
And so
I think it makes sense to distinguish, or maybe it doesn't make sense to distinguish between what actually happened, because it might be something that is related to your deployment. I don't know, like some script failed that updates the servers, or in your canary you failed to see some problems, and you kept rolling instead. You kept rolling out instead of rolling back, or it might be, well, there was a bug, and then it requires another commit and another deployment to fix it. So we can distinguish. We can say, okay, this is the infrastructure thing that went bump, and no, this is a bug that needs to be fixed. And then one can argue that in first case it is a deployment problem and the deployment is not over, but in the later case it's actually not a deployment problem. We deployed whatever we need to deploy. It's just not the right thing to work correctly. But should we distinguish that, or is just in the matter of the day the quality is the quality of the user experience, and it doesn't matter if it doesn't work because we didn't roll it right, or it doesn't work because there is a bug there?
yeah, I think the kind of the heart of the question I was asking is like, when do you personally feel your responsibility is over for the deployment, right? So it's always like a very uneasy feeling, because like Baruch, you gave some like good remediation information. Like, let's say something didn't go right, it's problem determination time, right? You're in some sort of window. Do you roll forward? Do you roll back? How sticky is the deployment? Can we roll back successfully? If you're fighting the MTTR metric, you have to restore at some point, right? And so that's usually it. It's just like, hey, do you feel personally on the hook for something? I remember it used to be a detriment to my happy hour. We would have to like, for me, I don't want to pay full prices for drinks, so happy hour is like 4 to 7. And I was like, let's get this deployment over by 5 so we can go and, get half offs, right? And it's always like, I know I'm going to get the alert. Let me not have too many, or you know what, this time it's my turn. Let me drink a little bit more. But yeah, that's usually it's a very human centric problem. Also, it's like, go back, go forward. The irony of it, like when you look at like it's the machine versus the human argument, right? Going back to automating the yes, I actually might bring this point up in the talk. I might change my talk. I have a week before that. So for one of the other points is doing systemic work is actually very human centric. So the other question I always like to ask people is like, when do you roll back, right? So this kind of like giving you kind of the answer here. It's like, everybody will say, if there's a problem, right? So like Baruch was saying like, hey, if we're violating something, or Kat's saying the user logged in and had a bad experience. But rollbacks can be very subjective, right? Like I was not willing to roll back because my bonus depended on it. Like I'm MBO'd on delivering a feature. Rolling back is not delivering the feature. And so like it's a lot of negotiation that you have to do. Like, are we going to roll back? Can we not fix it? And that's usually part of like negotiating, I guess, right? Like, hey, what would be the best decision given a situation? So I might add that core.
It depends on the scale of the problem. For me, like if we're talking about an app that has, 100,000 unique active users a month. If we're talking about rolling back an update, whatever is broken had better be fucking significant. If it's like a mild graphical glitch or a bug that affects 1% of users, maybe you don't roll back unless it's catastrophic and it's really, really bad for PR or whatever. Then you fix it. But if it's something that's like a catastrophic failure affecting 70% of your 100,000 users over a month, roll it back.
Yeah, no, but first of all, you shouldn't get to the situation when you are 70% into your progressive deployment and only then you figure out that you have a problem. The other aspect is that if your build is repeatable and fast, and your software is written, it's easy to deploy and it's fast to get up, then what is the difference in time spent between a rollback or a fix and commit?
Yeah. Then it depends on the complexity of the problem.
Yeah, of course. How long it will take you to fix it. Yeah.
Yeah.
That's the real question.
Yeah, those are always very like, unless you're in the situation, like every application is different. Like what Kat was bringing up, right? Like, hey, it's not one size fits all. The level of effort or level of urgency is different than hey, what's for lunch here at the building versus I can't cash this check on my phone, right? Yeah, so like everything is a little bit different. Usually, a lot of times, because the systems we deal in are so complicated. There's complicated infrastructure, and there's complicated infrastructure. There's complicated application infrastructure, and the applications are complicated. A lot of times, sometimes even if we're doing safety things like doing a canary release, we're segregating some of the traffic, trying more and more and more. There's always times for incidents, right? There's things that happen at scale you just can't predict. Like there might be some sort of database failure that you have so much load you didn't foresee it. Your clusters aren't scaling fast enough. There was like a runaway success or a thundering herd. This is very SRE type topics, right? Like how do you rectify for that, and how do you remedy that? And so there's always a lot to go wrong, but for the bulk share of getting to the yes, if you passed all these tests, right? Like if you passed the load test, the soak test, if you did everything that would make sense, you could go in with a lot of confidence that we know what we're doing at this point.
Yeah.
The Harness site still calls it continuous delivery, not continuous deployment. Do you personally still want a manual baby gate for safety for the actual deployment? Or are you comfortable automating the deployment too?
It depends on the organization. I'm comfortable doing 100% automation. From my definition of like if there's like more than one CD, like continuous deployment versus continuous delivery. Continuous deployment is more the mechanism, right? Like, hey, if there was no checks, like, am I able to? It's very happy path. Like, is it technically feasible for me to go from commit to deployment without anything touching it, right? Very little testing. Do we have some sort of way just to go build, deploy, and that's kind of continuous deployment. You physically have the access to do that, and that takes skill set to do that, right? Like you have to be using a stack that is conducive to doing that and continuous deployment. Where delivery portion comes in is a lot of the orchestration of confidence steps, right? Okay, are you running a soak test? Are you getting an approval? If it was up to me, I would automate. I would automate pretty much all of it, right? Like there's no need for a human intervention. We definitely support customers that are under different risk frameworks, right? So we have federal customers, we have insurance customers, we have people who are credit card vendors and PCI, right? And so they have a little bit different risk framework that they do have a human element of expertise that's looking at it. It's always a very difficult thing. Like it's always one or the other, right? It's either you automate everything with very little resistance, which is more continuous deployment, or you're a totally manual process. Like what the ironic saying is, it's easy to automate everything except the button push, right? So folks want to automate all the way up to a point, push the button, and then let it keep going. Doing that is actually more difficult than either side, right? It's more difficult than 100% automation. It's more difficult than like in terms of level of effort to build something like that versus complete manual. And that's something that the Harness platform does really well. You can have as many manual gates. I know it's like a shameless plug. You have as many manual or gates as you want, and it makes it very easy to make it as manual, automated, or anything between as you want. I think.
Yeah, no, but the problem with the manual gate is not obviously how hard it is to implement it or how easy it is to press the button, but what is the level, the expectation of level of knowledge that you require from the approver? Because what we say, and that's my problem with this approach, is that okay, we build a very elaborated pipeline, we baked tons of knowledge into those quality checks, and we came through the quality gates to this point where now a single person with, as we spoke, limited capacity for knowledge is now supposed to make a decision which is equivalent to all the elaborated tests done by tons of different tools and doing it fast without having any knowledge. For me, those types of last minute approvals are just, having someone to blame if something goes wrong. It doesn't really add anything, and the person that is supposed to make this decision is actually incapable, by definition, to make a knowledgeable decision there.
It gets difficult. Yeah, if you kind of take a look at I'll talk about what it looked like at the bank where we had the most, let's say, it was the only time I had to go through approvals to deploy something, right? It's usually some VP that's higher than me would look at the tickets, right? Okay, let's look at mainly it was ServiceNow, right? So we had to put requests into ServiceNow, and he or she would kind of look at all our findings. So we would attach all the findings. Say, here's the output of all the tests that we ran. Here's the infrastructure that we have it on. Here's all the places, we have the specific format that's copy paste, into this Word document that we would attach into the ServiceNow ticket. So the approver will make the final approval, and then we use that for teams saying, okay, we got approved, go ahead and push it in.
So, but that defeats the purpose. If you already have all the checks and you have all the results, then you have an algorithm of how to act based on those checks and results. And if you say, all right, I have all the critical tests passed and some percentage of non-critical tests didn't pass, and you expect this VP to approve this situation, but on the other side, you expect them to reject the situation when any of the critical tests are passed, then you just code this algorithm. And on the other side, if this algorithm is not defined, then you have a Russian roulette. You just let someone make decisions based on insufficient information, and the only purpose for that is to have someone to blame when something doesn't work. The more I think about it, the more I'm convinced that the whole idea of having a manual gate in the end actually harms more than it helps.
I think it depends on the institution. I'll give you kind of some rationale behind why there's sort of checks and what there's ways to automate around it. In 2020 would be what the approval. I'll make a very car specific example. Baruch, congratulations, you're looking for a new Porsche Cayenne. Congrats, the big one. Get the good one, Baruch. So Porsche is automated. I'm a big Porsche fan here. So as automated as their factories are, there's still somebody at the end of the assembly line, wiping a glove. He or she knows exactly what millimeter every part of this Porsche should be. And if you watch their how it's made videos, that you always what's this person rubbing a car? Stop it. It's mine. It's not yours anymore. It's just that the approver in a best case has domain knowledge of the application, right? So he or she knows what deviation is. So if I was new to the team, let's say I was a new Kat, you're my approver. And I'm new to the team, but you've been on the team for 2 years. Kat would have domain knowledge of what normalcy looks like. And especially if I was a new engineer on the team, I have no idea what the baseline is. I literally don't know what was acceptable and what's not. We pass all the tests, but was there something when you're you're doing that type of last minute quality check? Was there something that I missed with the limited knowledge I have about the application? Usually Kat would be okay, everything looks like it lined up. Now,
we are not arguing if more knowledgeable person is better to take those decisions than less knowledgeable person. We are arguing about if it's even possible to a person have more knowledge and apply better algorithm that all the tools that you have in your pipeline building toward this knowledge. Because if the algorithm is simple enough, it should be codified, and if it's not, then it was just guessing at the stars, and you just look at a bunch of tests and you decide whether it looks better for you or worse. This is not how you define quality and go or no go to production. I understand how hard it is to give up control. I just don't think that in this point of time, for automated deployment and delivery, people can apply better judgment than machines.
I think I was going over that port. It's actually exactly what you're saying. A lot of times, let's talk about what a modern team looks like. let's say again, we're on a team. Most likely people will change teams like every 6 months to a year. So like a lot of that institutional knowledge is not there. So we're already faulted by that. Like the number of people who know the application very intimately is reducing the pool. And so we have to do things off of historic baseline. So this is where you're going to look at like monitoring data, you're looking at trending data. And that's actually one last plug for Harness. Like a lot of times, let's say us three run a DevOps team, or us three were like on some sort of team that's like, hey, we're a platform engineering team. We're no longer responsible for one app, but we're responsible for hundreds of apps. Like there's no way we have context of every app. Like it's impossible because we're not on those teams. With the Harness platform, we actually look for deviation, right? So going back to that automation portion of it, we know what's normal, we know what's not, especially if we roll in and out of projects. Like it's kind of doing that for you. So if leveraging a platform like Harness, or leveraging the Harness platform, we're baselining for you and also looking at deviations occurred, roll back, like the black kid killer. You're screwing up. Get out of here. Get stop it. You know. So that's the hardest part, right? Like that. Having a knowledgeable human is always hard to find because we all change jobs.
Reason to leave it to machines which don't switch teams. So
yeah, they're there,
right?
Yeah.
So yeah. So I mean,
I welcome our robot overlords,
right?
Personally.
Right?
I don't want to have to do menial tasks anymore as an engineer. I don't want to have to make stupid decisions like that if my automation has already determined that to the best of its knowledge it's going to run, it's going to build and it's going to run, and the users are not going to crash it. Then
yeah, I mean, take a security decision, okay? You don't need to approve a security decision. You have a report from X-ray, and it has certain amount of critical, some amount of major, minor, trivial, whatever. So you, as a subject matter expert, can reason and say, okay, I'm fine with minors which are not in my core application, but in my dependencies, I don't know, I'm not a subject matter expert. But if you can express that as a sentence, that's a codable algorithm. There is nothing there that the machine cannot do for you in this scenario. And the problem is the person, this VP, who's in charge of pressing the button, they don't have this algorithm in hand because they're not security expert. So I don't know how can you justify it, except of just being comfortable of, how do you did this motion with your hand to rub your hand over the car. I don't know how it helps, but if you make it feel better, maybe it's not enough of a reason. If you don't lose money on it and your competition are not doing it completely automatically, and thanks to that rolling features faster and being more protected with security and saving more money, maybe it's fine. But I don't see any other reason for that.
Damn, Baruch, you're a bully.
I am. I'm automating people out. Yes.
By humans. By humans.
Well, with this extremely optimistic note.
Humans don't know. Yeah, I think it's where there's a lot more automation, just reflecting like the last 10 years. Like absolutely, like the amount of like human pushes are a lot reduced, right? Like, it's basically certain organizations just for the risk framework, they need it, but those are becoming less and less, right? More even the most conservative organizations are looking to automate more pieces of that they have before. So it's definitely a walk, crawl, run. But yeah, that's exactly right. Like if you're not, your competition's going to do it if you're not doing it. So that's business these days.
Yep. So with that extremely optimistic note, I really want to thank our special guest today, Ravi. Thank you very much. It was a lot of fun, and I think we learned a lot. It was a fun discussion, and we are definitely looking forward to your session at SwampUp this year and to see you at SwampUp in Flesh and Blood next year. So thank you very much, Ravi. Thank you, Kat, and I'm Baruch. With that, thank you very much. And bye-bye.